Okay, I'm back, and so now let's finish the lab here. So now we're going to go down to procedure and look at these lovely pictures that I found for you from the internet. Um, First thing is you need to find an object that is roughly 12 feet away from you. So that's going to be the object that you're going to be finding. Now you could probably even do this lab inside your house if you want. Or if you want to go outside and get some sunshine or clouds, as the case may be, then you can also do it outside, so you might as well do it outside. But in this case, we've got this kid here in the picture, and he wants to measure the distance to that tree. So the tree is going to be the object, and we're going to assume that the distance is the letter Y. So first thing you're going to do is on the ground, so scroll on down to that next picture, you are going to measure on the ground a line which we're going to call the baseline, and it's going to be abbreviated by the letter B. And notice I've got it symmetrical, so that I've got the baseline is perpendicular to that distance Y. It doesn't necessarily have to be perpendicular, but you could do it that way. And I've got it symmetrical, so half of B is on the right hand side and half of B is on the left hand side. So I don't tell you how long to make your baseline. So you might want to experiment with it, and you're going to find out really quick what kind of a baseline that you're going to need in order to be able to get an accurate answer for this particular lab. Okay, then go down to the next picture, and it says to get at one end of your baseline and measure the angle that the baseline makes with the object. So you're really going to have to get down on the ground in order to be able to do this. You're going to take your protractor and lay it flat on the ground, and then take the ruler, and I recommend take the ruler and put it on top of the protractor, but I couldn't do that with Microsoft Paint, so it looks like the protractor is on top of the ruler. But really, it's probably better to put the ruler on the top. You can do it either way. And you're going to get down on the ground, and then you're going to use the edge of that ruler to look down, and then to look at the object with, and then that way you can pivot the ruler so that you can measure the angle that it's making. So you're going to measure that theta sub 1 there in the picture. Okay, then you get up, you go to the other side of the baseline, and you repeat it. So you're going to measure the other angle, which is going to be theta sub 2. So you got these two angles that you're going to be measuring with your protractor. Now, if you don't know how to use a protractor, go to the internet, and you'll find lots of YouTube videos that shows you the proper way to use a protractor and how to read the numbers. Because you notice that there's two sets of numbers, and if you get the wrong number, you're completely wrong on it. So you'll notice that one of the numbers will be the smaller number is probably going to be the correct number that you're going to be measuring. The other number, the bigger number, is what happens when you take 180 degrees minus the small number. So remember, you're probably going to be using the small number when you're measuring those angles. So now what have we got? So we've got the distance of the baseline, and we've got these two angles. Next, take your baseline. So let's say that your baseline was 6 feet divided by 2, so that would be 3 feet. So you'll notice that in the chart that is underneath it, it says for object number 1, which in this case would be the tree, the baseline, write down how many meters is your baseline. You can measure it in centimeters and then convert it to meters. Or for this particular lab, if you want to do everything in feet, you can. So this one I'm not picky about official metric. So if you want to measure it in either meters or feet, it makes no difference to me. But measure your baseline, then divide it by 2. So if you had a baseline of 6, you put down 3 in the next column. Okay, then you're going to enter theta number 1 and theta number 2 that you got with your protractor. Then you need to average them. So how do you do an average? Add them together and then divide by 2. Okay, so now what do we got? We've got a distance, then your baseline divided by 2, and we've got an angle. So now we're going to take those two measurements and plug it into the tangent equation, just like we did before, and we're going to solve for the missing side of the triangle. And that will, if you measured everything in meters, then that answer will be in meters. If you measured everything in feet, that answer will be in feet. Now, actually measure it. So then, get out your ruler or your tape measure and physically measure the distance of that object. And those two numbers should be fairly good. Okay, the next part says, though, to repeat with a further object. So now I want you to pick another object that is at least 5 times further away than the original object, and I want you to repeat the whole lab. So you're still going to have a baseline. You still measure the angles. You'll have different angles with your protractor, and you'll still use the tangent thing. You'll still calculate the distance. You'll still measure the distance and compare those two distances, and this time it may not turn out as well, but that's the whole point of the lab. And do you remember when we talked about the parallax formula? So the parallax formula was whenever an astronomer, he measured the angle that the star made, and that was in arc seconds, which was 3,600 times smaller than a degree. That's the kind of accuracy that astronomers have. And they would measure these angles in arc seconds, then they flip it, and then so 1 divided by that angle, and then that is going to be equal to the distance to the star in parsecs. So I wanted to give you a lab that kind of gives you a flavor for how astronomers have to measure the distance to objects by using angles, and just also to show you that astronomers measure things in a lot smaller increments than just mere degrees. So they use arc seconds. So you still need to do the post-lab questions, and there are 7 post-lab questions that I want you to do, and then you will email the completed lab to me. Alright, so I think that this one should be pretty fun for you to do, and you are going to be doing this next week. Let's see, when are you doing it? So the Monday class will be doing this on the 6th, and then the Tuesday class will be doing it on the 7th. Okay, so you can get started on that then next week. Bye.